Hi, everyone. My name is Will. I'm a principal product manager at Snowflake. Today, I'm here to talk to you about a new exciting product feature we're bringing to the market called Interactive Table and Interactive Warehouses. It's designed to serve sub-second analytic use cases for very large-scale applications. Today, in the BI and real-time analytics use cases, you usually have data split between two systems. One system is what Snowflake and a lot of the traditional BI vendors are good at, is complex queries and analysis on really large-scale historical data. Snowflake has made this relatively simple, but as we're seeing, there's more and more use cases in the real-time side where the queries are much simpler. People need near real-time access to data, and people are trying to do this workload at massive scale. What usually people do today is they split up their data platform into those two systems, one for historical access and one for near real-time access, due to a variety of reasons, some technical, some due to cost constraints. And this creates a variety of problems for folks. The first one is this adds a lot of complexity to our data platform. Now you have multiple infrastructure you have to manage, and there's no guarantee the data will be always consistent in two different systems, especially for use cases where you're sampling data or you're doing approximation on data counts. That can lead to customer trust issues. Sometimes when you're doing reports, your real-time system doesn't report exact same number as your historical system, and people have financial discrepancies between the systems that can lead to even financial losses for some institutions. The other issue with a deployment like this is the system is inherently more complex. You have a data warehousing solution, and then you also have a real-time database solution, and manual configuration across them, doing ETLs through the systems are all kind of error prone. And try to govern the data across the systems is also very complicated because each of the system might have different security posture. And all those leads to increased total cost of operation. That means you have essentially two layers of infrastructure costs. You need different teams to maintain the systems. You need to monitor them differently. You need to scale them differently, etc. And we are thinking about this problem very deeply as a very, very good data platform company. What can we do to make people's life easy? And what we want to do is we want to combine those two systems to give you an offering that's optimized for both low latency, high concurrency access at very affordable cost, as well as a system that's capable of running large scale complex analytics on exactly the same data set. So today, we're bringing to you interactive analytics from Snowflake that can combine those two use cases together on the same platform. There's a few key benefits here. The first one is, in addition to what Snowflake can offer today, we're offering you the ability to do sub-second analytics. This allows you to get consistent serving latency on a very large scale. You will not be impacted by noisy labors. Are very unlikely to hit elastic scaling boundaries. The dashboard takes 2 seconds to render today, well, much more likely to take 2 seconds to render tomorrow. The second piece is, as we see a huge growth in AI and agentic workloads, the AI agents generates a massive amount of queries at very concurrency, and each one of them will need to be served very quickly for great user experience. And traditionally, people use a variety of caching and other specialized data store techniques to serve this use case. And we're thinking, okay, why don't we bring all those together into the same platform with the same data serving layer that powers those kind of workload at massive scale? This is what Interactive is capable of doing today, is we can serve very high concurrency workload today. Cool. Now let's talk about how interactive table and interactive warehouse works. There are two pieces we're introducing. The first thing that we're introducing is a interactive table format. This table format, you can load data from any kind of batch sources. For example, if you have Parquet files in S3, or you have a regular Snowflake table, or if you have a batch source such as a Iceberg table or Delta Lake, you can load this into interactive table. Interactive table has added metadata and index that allows it to be accelerated with a new set of hardware and software engine that we're doing here. Once you create interactive table, what you can do is you attach it to a new entity we're introducing called interactive warehouse. Interactive warehouse is powered by an engine that's specifically tuned for this workload. It runs on different hardware, and it's designed to serve very high concurrency, very low latency queries at massive scale. The warehouse and then the engine will utilize the additional metadata written to the interactive table to accelerate any kind of query you issue to it. At the same time, the interactive warehouse will pre-warm the cache by your instruction so that all the data in the interactive table will be loaded into the hardware proactively. And then as soon as you issue a query, the data will be available for serving the query you issue to it. And this will give you a very, very good experience on building apps based on the current batch sources today. But what's more exciting about interactive table is we're introducing the capability of streaming data directly into it. What streaming data means is now you can connect any streaming sources, such as Kafka, Kinesis, from any platform that's compatible with Snowpipe, directly with the interactive table with no intermediate stages. This pipeline is entirely event-driven. So that means as soon as something is happening in your data source, they can be made available and visible in the interactive table. This allows you to power a lot more real-time use cases that are otherwise impossible on Snowflake platform today. The first experience I introduced, where you're loading data from batch sources, can also be done incrementally using a technique called dynamic table, where you can specify a lag to incrementally refresh from the batch sources. That usually takes in the realm of 2 to 5 minutes. But with the streaming workload, where you can stream data directly into the table, you can cut that number down to a few seconds. So those two can serve very, very different use cases on very different timescales. The second piece on streaming ingestion is currently in private preview. Please work closely with our account team, and we can enable this experience for you. Now let's get into a little bit more details, how this works. The first step is you want to create an interactive table from any source table that you have. And what you can do here is you're doing a create table select job. And this is very similar to a regular ETL query that creates a new table in the format. The second step is you create an interactive warehouse, which provisions the hardware as well as the query engine necessary for serving interactive workloads. The last step is you add the interactive table to the warehouse. By attaching this table to the warehouse, it instructs the hardware within the warehouse to start pre-warm the data in your table. And as soon as your query lands, it will be served by the warehouse immediately. And don't worry, even if the warming is still going on, Snowflake has intelligence in place that will prioritize to query the data that you're asking it for. So even if you're missing the cache, the performance impact will be minimum. What's unique about this setup is you can attach the same interactive table to multiple warehouses that serves and limits the impact of your different use cases to each other. In this example, you can attach interactive table to two different interactive warehouses. For example, you can have one serving external use cases and one serving internal use cases. That ensures your internal analysis workflow on the interactive table will not disrupt your external users' experiences. At the same time, you can also mount the interactive table on a standard warehouse. By doing that, you can use all the elastic compute resources that Snowflake can offer, and this will be really, really useful for ad hoc analysis, where you don't need a warehouse to be on 24/7. And through attaching the interactive table on a standard warehouse, you don't get the additional acceleration. Instead, you get the standard performance that you get on Snowflake. All right, who's ready to see some demos? Let's look at the first demo. This is how to set up and use the interactive warehouse. What I'm showing you here is a Snowflake notebook. And as you can see, the first thing I want to do is do some checking and verification to make sure the things are set up. Let's make sure all the libraries are running. And then let's look at all the parameters for the account and make sure the interactive warehouse is provisioned for this account. Indeed, it says yes. All right. So next thing, what I'm going to do is I'm going to set up myself as the user, which database and which row I'm using it on. The first step I'm going to do is create interactive warehouse and turning it on. The interactive warehouse itself can be viewed as basically a cluster of virtual machines that has CPU, memories, and local SSDs for caching. So what I'm doing here is I'm creating an interactive warehouse. I'm giving it a name, interactive demo B. I'm using the extra small, setting the cluster size to 1, and then say, okay, I'm going to create this one. And then I say, okay, let's get it done. Once it's created, what you want to do is you want to bring up the hardware to make sure it's up and running. So what I'm going to do is I'm going to resume the warehouse. And then says success. Great. All right. So the warehouse is probably being bought up and going to run. Let me go to the warehouses panel and show you what's in there. In the warehouse panel, we have interactive demo B that's just started now. Okay, great. Everything's running. Let's go going from there. The next step you want to do is you want to create a interactive warehouse with an interactive table. In this case, what you do is you take a regular table, run this through a standard warehouse into an interactive table. Right. So for this exercise, I am going to use a adaptive warehouse. In this case, I'm doing use warehouse adaptive, and I am switched over here, as you can see. In the next step, what I'll do is I'll take a source table and create the destination table using this create statement. So I'm going to run this, and it's going to start execute. This exercise will take a while because this is a relatively large table. And usually in production, what happens is this can take a few minutes to a few hours if you have terabytes or petabytes of data. While this is running, I'm going to explain the next step. So once the table is created, what I will be doing is I'll be attaching this table to the interactive warehouse where the cache of the table will be proactively warmed using the interactive warehouse. All right, so that is still running. Let's take a look on where it is into the query history. Looking at the current one that's currently running. So usually it takes a minute or so. There we go. After this, what I will do is I'll switch over to the standard database. I will change the warehouse to attach the table to it. After attaching the table to the warehouse, what it does is it starts to proactively warm the data into the warehouse. So in this case, what I'm going to do is I'm going to switch over to this warehouse, load the table up, and start querying it. For this exercise, one thing I've done is I've proactively turned off the caching so that you see the real performance of the warehouse itself. The query is relatively simple. The query basically says, let's look at the page views from some visitor table filtered by some ID based on some data, and then sort it. And then after I get the data back, what I will do is I will run a plot of this. So let's run this for one time. Okay, great. As you can see, for that particular query I just showed you, it took 0.1 second. And this is pretty typical for a interactive warehouse's performance. To show you as a comparison, what I will do is I'll go back to a standard warehouse. In this case, I'm using the extra small, same size, disable caching, using the same database, and querying a regular table. Okay, run through that, and then basically see I'm looking at the same table, but not attached to an interactive warehouse. This is running it through the standard warehouse. Same code, same everything, except it's coloring things in green, and I run that, and you can see this time it took 0.8, 0.9 seconds, so it's substantially slower compared to an interactive warehouse. And this is pretty ideal for the kind of query shape that we're serving or testing here, which is typical for dashboards, where you have very specific filters on the data you're testing and running on. And this is ideal for interactive warehouse in that it will allow you to prune the data down to very few records in a very effective way, and we can execute them highly concurrently in parallel. So what I'm doing here instead is I'm showing you another mini benchmark on the data. So this will be running and measuring on a interactive warehouse versus standard warehouse and show you sort of the performance difference, right? But typically what you will expect is through a run like this, the interactive is anywhere between 20 to 30% better for a relatively complex query. Okay, so see, this is sort of like what I would expect. You will see variations in the performance depending on the kind of query shape you run in production. And that concludes the first demo. There are a few key use cases that interactive table and interactive warehouse will enable today. The first one is what we call real-time dashboarding. So imagine you want your user to slice and dice dashboard in real time with really, really good responsiveness. This can be both internal as well as external. The second use case is what we call data-powered APIs. This is typically for people who are building mobile applications who want to show some kind of analytics for your end user. Imagine you are building a shopping app for the stores, and then the store owner will want to check out their store's performance in their app. Or you're building some kind of fitness tracking app for your end user, and their users want to see their own body's health metrics in their apps. This will be a very good database to power those kind of short-term, very targeted aggregation kind of use cases. And lastly is what we have mentioned earlier. It's really, really good for powering AI or programmatic-driven workload where there's super high concurrency demand with very low latency needs. And all those three use cases can be served through interactive analytics powered by Snowflake's interactive table and interactive warehouse. Now let's jump into a demo that shows how we can build apps around this experience. What's very typical for interactive warehouse is it's really good at powering workload generated by AI agents, because AI agents tend to generate massive amount of queries, and you want each one of them to be very low latency and be very responsive. What I've preloaded here is a data set from US DOT around US flights departure information. This contains data all the way from, I think, 1987 to this year. So I'm just going to run a quick query and check things out here. Origin, destination, average delay from various city pairs. Let's say, for all the flight departing from SFO, which one is the longest? So where origin equals to SFO. And then this will show you, oh, wait, some of them actually have negative numbers. That's kind of interesting. All right, so let's go into our AI analyst. The AI analyst for the first one, we're using the semantic view creation tool inside of Snowflake. It's very straightforward and simple. All you need to do is pick a table that you want to do analysis on, and pick up the dimension, create the semantic model, give the dimensions inside the data some meaning, right? This one took me probably like 5 minutes to create and label, do some like basic aggregations on the table. From here, once you have created the table, what it does is you can start playing with the AI agent on it. In this case, the agent will be using a extra small warehouse with this data set to query the data that's inside of the warehouse or inside the table in this case. So what I'm going to do is I'm going to ask it a question. So how many flights are delayed by more than 30 minutes between SFO and JFK in 2023, right? So this is a relatively straightforward question. And the analyst, what it does is it will look at a set of queries and execute and come back with a result. So this one took a little bit of time, and then go back with 1090 delayed flights. What I'm going to do is I'm going to switch this over to a different analyst. It's almost the same with a subtle difference here. It's using an interactive warehouse, same size, so interactive small. That one we just created. So in the first demo, I'm going to ask the same question again. And what the analyst does is it generates the question, the query, and executes it. What's kind of interesting is if you switch into the query history view and look at the two queries it has generated, and look at their runtimes a little bit. So in this case, in the interactive small warehouse, the query took 46 milliseconds. And then the same query in the standard warehouse took 1.6 seconds, which is substantially longer compared to the interactive warehouse. And with a setup like this, you can usually get really, really good performance through interactive warehouse and interactive table to help you accelerate your AI agents, especially when they're substantially query load. For this next part of the demo, we'd like to show you interactive table with real-time streaming ingestion capabilities. What I have here on screen is a very simple application. You can select some queries through a template. You can set the kind of concurrency, and you get some metrics back when the queries are ran. What's behind the scene is you have the client issuing some queries to the application server. The server will try to run those queries concurrently as quickly as possible against a data set that we have already loaded into an interactive warehouse. At the same time, the application server will measure basically how long each of the query has taken and emit that number through a Snowflake streaming pipeline directly into interactive table. This is sort of the real-time portion of the system. This is not possible today easily through Snowflake. And what we'll do is the application server will return back the metric from the interactive table directly back to the dashboard. So what you will be seeing here is on the left side, this is the issuing part. And then on the right side here is querying the metric back from the backend. What's kind of cool here is we're eating our own dog food, basically. So as I'm issuing queries and running the queries will be sending those metrics directly to the backend in real time, and we're refreshing those metrics back directly in real time from the backend. And as you can see here, each of the query here is taking somewhere between 0.3, 0.4 seconds, and I can just keep issuing them, and you will see more and more data refreshing back from the backend. What's kind of cool here is I can run this with much, much higher concurrency, and you should still see relatively stable results. What I will do here is I'm going to issue a huge amount of queries, 100 of them concurrently, and then let's see how they're performing when we're fetching them from the backend. As you can see, even as the concurrency is increasing, we're still sort of staying within plus minus 30% range of the query latency. This is fairly typical in a large cluster with a lot of people issuing slightly different queries in high concurrency, and you can use the system to provide relatively reliable performance to all of them so that their dashboard and their user experience are unaffected by other people using the same system. And this will also work on any kind of data that's streaming in real time. So that's pretty cool. As I've mentioned before, interactive table and the interactive warehouse is pretty ideal for a lot of low latency interactive use cases. And a prototypical use case is powering real-time low latency BI dashboard. You get amazing accelerated experience when you are slicing and dicing your data. What I'd like to introduce here is our Senior Technical Alliance Manager from Sigma Computing to show you a demo using Sigma BI tool on top of interactive table and interactive warehouse.
Thanks for the intro, Will. Hi, everyone. My name's Shawn Namdar, and I work at Sigma Computing. Today, I'm going to run you guys through a really sweet demo that I've built, leveraging Snowflake's new interactive tables and stress testing them against regular tables, specifically in the context of BI. I've gone through and I've built out this on top of the TPCH SF1000 line items table, and I'm leveraging large warehouses for both regular and interactive. So, without further ado, let's hop into this. For the test, I've got two connections, and we're going to start running the queries right now. I've leveraged this 6 billion record table as a starting point, and I've created two graphs and a pivot table for each connection. So we can see that the tables at the top have come through. They're just a really simple select statement. And it looks like interactive tables have actually just gone and finished their graphs as well. Let's hop over and see some of the queries that we generated and the times that it took to calculate. So it looks like just about 4 seconds for that top table. Like I said, Sigma's just doing a limit 10,000 records there, and then about 8 seconds for the two graphs. Now, the graphs are running for the quantity by receipt date and ship mode and the total price by receipt date and ship mode. Speaking of the graphs, it looks like the regular table graphs just finished at about 59 seconds. So again, 8 seconds versus 59 seconds. That's about 7.5 times faster. It's pretty good speed increase, I'd say. And then let's look at the pivot tables. Still no result. Oh, I spoke too soon. Looks like the interactive tables pivot table just finished, clocking in at about 1 minute and 16 seconds. That's pretty quick. Yeah, the query for that is a select statement with a couple subqueries and a CTE. All around pretty strong performance though. A 6 billion record underlying table with pivots broken down by supplier and day, calculating out the total price. It's a pretty complicated query right there. And it looks like the pivot table for the regular tables just finished as well, coming in at 1 minute and 55 seconds, so just under 2 times faster for the interactive tables. Well, I hope you guys enjoyed my quick little demo. Thanks, everyone. Really excited to see where interactive tables go and what they mean for BI on top of Snowflake. Back to you, Will.
Thank you, Shawn, for the amazing demo. As you can see today, we have covered interactive table and interactive warehouse. When paired together, they give you really, really good performance on low latency interactive workloads and ability to access your data in real time. What I'm showing you here on screen are resources to get started with interactive table and interactive warehouses today. We love to invite you to give those a try on Snowflake today and get started building. Thank you.